All right, today we're going to talk about special right triangles. The two special right triangles we're going to talk about are 30, 60, 90 and our 45, 45, 90 degree triangles. Big thing that I want you to understand is that when we go to find missing side lengths using these patterns that we discover, it's not the only way to do it. So I'll show you how you can still use the Pythagorean theorem in some cases in order to find missing side lengths, etc. Okay, so for example, the very first one, in a right isosceles triangle, that's a 45, 45, 90, and just so you understand, it actually comes from a square that got basically cut along the diagonal, okay? All right. In a 45, 45, 90, since the side lengths of the square are the same, these two side lengths are going to be congruent to each other. The hypotenuse is going to be x root 2. All right, so let's show what that means, okay? If this side length is a 5, well, since the two sides or legs of the right triangle are equal to each other, this is also a 5. So if I at least knew that part, I can use the Pythagorean theorem saying that 5 squared plus 5 squared equals c squared, okay? 25 plus 25 equals c squared, 50 equals c squared, and then I go and take the square root of both sides, and then I've got a c equal to the square root of 25 times 2, or c is equal to 5 root 2. So it's 5 root 2. So the pattern is that it's always x root 2. Okay, so to show you another quick example, it would be like 8 root 2. That would be the pattern. All right, so let's take a look at these two examples over here. Okay, so the idea is to understand 3 root 2. 5 root 2. Okay, and if you can't remember the pattern or you don't know it, again, you can always rely on the Pythagorean theorem. The benefit of the pattern is it just makes it go a lot faster. So on our next example, 6 root 2. So a is equal to 6 root 2. On number 2, now they're just asking you to go the other way. If this is 2 root 2, drop the root 2, and it's 2 root 2. So x is equal to 2. On our third example, okay, this one's a little bit trickier. The first thing is to understand that these two pieces are the same. So whatever x is, then y is. Okay, they're equal to each other. Because if anything, tick, and again, they're the two legs of an isosceles triangle. All right. So two options here. Number one, we know that this side is x root 2. We could set x root 2 equal to 9 and then solve for x. And go divide by root 2, and x is equal to 9 divided by root 2. We studied that you're not supposed to have radicals in the denominator, so therefore we're going to rationalize, and now x is equal to 9 root 2 divided by 2. So if this is 9 root 2 divided by 2, y is also 9 root 2 divided by 2. Now, is that the only way? No. Okay? If you understand that, again, tick, that these are equal to each other, I could have done x squared plus x squared is equal to 9 squared, and then solved for x using the Pythagorean theorem. Okay? All right, last one. So tick, if the left side is 4 root 3, this x value is also 4 root 3. And then the y value is going to be 4 root 3 times the root 2, or 4 root 6. All right, the second type of special right triangle that we're going to talk about is the 30, 60, 90. The big idea that I want you to understand is that I always try and find the side opposite the 30 first, okay, because the other two sides are based upon the relationship with it. Okay, so the first side we're going to label as x. That's the side opposite 30. So opposite the 30 degrees is our x. Okay, opposite the 60 degrees is going to be x root 3. So x root 3. And then opposite the 90 degrees is going to be our 2x. Okay, so our right angle is all the way down here. And if you think about it, The bigger the angle, the bigger the side opposite. X root 3 is roughly 1.7, so we went from 1x to 1.7x to 2x. The side length got bigger because the angle got bigger. All right, so what does that mean in terms of, our pattern? Well, if this was equal to 8, well then this is 8 times root 3. And if this is equal to 8, this is 2 times 8, or 16. That's why, I started with the 30 and then I figured out the other two sides based upon it. Now, what if I start with the hypotenuse and say that this is 20? Well, then I cut that in half and I get 10, and then I multiply it by root 3. And if I started with the other side and had, say, 9 root 3, well, then this is 9, and then this is 18. So there's a relationship between the three sides. All right, let's take a look at this one, okay? So first identify that the 5 is opposite the 30-degree angle. So that means that my A value is 5 times root 3, and then my B value is twice as much. Okay? Side D is opposite the 30-degree angle. So I'm going to take the hypotenuse and cut it in half and get 6. Then once I know that this is 6, all I do is multiply by root 3, and I got 6 root 3. In example 7, okay, I start by finding the side opposite the 30 first. Well, this is my x root 3 side, so I just drop the root 3 and x is equal to 4. Then I double and I get 8. So x is equal to 4 and y is equal to 8. Okay, over here, this is a tricky one, okay, because this is x root 3, this is 2x. So like the tricky one that we had on the front side, I'm going to set these two equal to each other to solve for x. So I'm going to say 12 is equal to x root 3, and then I'm going to solve for x by dividing by root 3, dividing by root 3, and then 12 divided by root 3 equals x. I'm going to rationalize by multiplying by root 3 and root 3, and that's going to give me a 12 root 3 over 3 equal to x. These two are able to simplify down to 4 and 1, so now my x value ends up being 4 root 3. So 4 root 3, and then when I take that and I multiply it by 2, I get 8 root 3. So my e value is 4 root 3, and my f value is 8 root 3. Okay, so that's all we have to understand. Okay, but again, like if I wanted to take this one and I didn't understand this idea of, solving for x, there's always another way. Okay, I could have used the idea of the Pythagorean theorem and said, all right, x squared plus 12 squared is equal to twice the x value squared. So now I got x squared plus 144 equal to 4x squared, and then I could just simply solve from there. Okay, so there's always another way. The only benefit to understanding the pattern is that it just makes it a whole lot faster. You don't have to do any solving at all. And the pattern is, if I have a tough one like this, in which the root 3 is being multiplied in, I divide by 3 and then put a root 3. That's the pattern. All right, that's it. After this, it just comes down to practicing it.